We're going to look at this video at distance time graphs or displacement time graphs. So for a distance time graph, your displacement or your distance is on the vertical and then your time is on the horizontal. If you've got a diagonal line here, that represents a straight diagonal line, that represents a constant velocity, and velocity is given by the gradient. So if I drew another line on here, the second thing, another straight line, the second thing I've just drawn in red, it would have a greater velocity than the one in blue. Okay, this middle one here, if we just look at it, if you look at what's happening here, the displacement is not changing. So a horizontal line represents the body is at rest. And then here, this is our displacement. It's returning back to where it was, so it's coming back to where it started. Or you could say a relative to where it started, it's got a negative velocity. Okay, so positive velocity, velocity of 0, i.e. it's at rest, and then a negative velocity where it's coming back to where it started. So here we'll see here, this example we've got, it says an athlete is training by jogging in a straight line. An athlete is training by jogging in a straight line. And it says calculate the velocity of the athlete during the first 2 seconds. So for the first part, we're looking just here at this wee section. So velocity, remember, is just the gradient. So we'll just say our velocity is the gradient. And it's gone up 5 as you've gone across 2, which is 2.5 meters per second. For part B, it says describe the motion of the athlete between times of 2 seconds and 5 seconds. Okay, so we're talking about this wee section in here. In that wee section, if you look at what's happening, it's a horizontal line, so the motion of the body, it's not moving at all. It's stationary, it's not moving. Next one, part C says calculate the velocity of the athlete at 10 seconds. So 10 seconds roughly would be here. So it's constant velocity, so we could just find this whole gradient, so that confuses people a wee bit. So 10 seconds would be roughly about here, and at that time it's got a constant gradient, so we can just find our gradient. So C, just say the gradient equals our velocity, and it goes down 11, and it goes from 8 to 14 seconds, so it's in 6 seconds, which would work out to be minus 1 5/6, which is the same as minus 1.83 meters per second, and that's to 2 dPs. Part D says find the total distance traveled by the athlete in 14 seconds. Okay, so for part D, let's just think about it. He's gone out 11 meters this way, and then he's come back 11 meters this way. So that's a total of 11 plus 11, which is 22. 22 meters. Is it meters? Yes, it is meters. 22 meters, and that is it. Okay, next example says, this next example here says, an airport bus travels along a straight road for 600 meters at a constant velocity of 75. Constant velocity in 75 seconds. It stops to collect a passenger for 2 minutes before traveling 1 kilometer in the opposite direction in 100 seconds. Sketch the displacement time graph, and then it says what is the velocity of the bus in each phase of motion. Okay, well let's just sketch this first. Okay, so my sketch, let's see. Okay, right, it starts off with our horizontal line here. Starts off in the first 75 seconds, it goes 600 meters. Is that right? Yep, with 600 meters. That's the first wee stage. And then it stops for 2 minutes. 2 minutes would be 120 seconds. So that's going to take you up to 195 seconds. He stopped. And then he goes 1 kilometer in the other direction. So sorry, I should have marked on that was 600 meters. Let's do this right here. Mark everything on. That's my displacement in meters. And here, this is my time in seconds. So, sorry, we did our first 600 meters in 75 seconds, stopped for 2 minutes, or 120 seconds, takes us up to 195 seconds. And then he goes 1,000 meters or 1 kilometer, that'll take you back to minus 400 meters. So 400 meters beyond, back the other way, past where you started really. And he does that in 100 seconds. So that's going to be 295 seconds. So 295 seconds. So that's what you've got. Okay. So we've got section 1, section 2, and section 3. And what we've got to do is, it says, what is the velocity of the bus in each phase of motion? So we'll just do it here. So phase 1, the velocity. I've gone 600 in 75 seconds. If you do that, you'll get 8 meters per second. In phase 2, my velocity, hopefully we realized from the previous example, horizontal line represents stationary, so the velocity is 0. And the last one, my velocity is, I've gone minus 1000. I did that in a nice one. I did that in 100 seconds. That works out to be minus 10 meters per second. And his velocity, his speed in the last section would be 10 meters per second, but velocity, you need the direction. Okay, right, bear with me. This next example is not nice. A lot of explanation. If there's any physics students watching, you may be disagreeing with what I'm saying. This is my simplified way of doing this. Okay, it says, example, a ball is dropped from a height of 10 meters. It rebounds to half the previous height after each bounce. Sketch the displacement time graph showing the motion of the ball until it hits the ground for the third time. Okay, right. Whew. Okay, we've got our displacement. And that's in meters. Okay. And then we've got our time. That's going to be in seconds. Okay, starts off, imagine these are straight lines, starts off at 10 and it drops down, hits the ground. Okay, so this is relative to the ground, so this would be 0, so it would make sense, it's hitting the ground at 0. And it bounces up to half its speed, or half its distance, so half of that is going to be 5. So it really should be the same sort of gradient as the last one. All of these things should be parallel. So this next line I'm going to do is parallel to the first one. So it goes up to 5, and it goes down again. So again, this line I've just drawn should be parallel to the first diagonal line. So and then it bounces up to half again, so it's 2.5. So 2.5 is here. And then it's going down again parallel to the other diagonal lines. And that is it. Right, let me have a think and see. Right, ball is dropped. So let's just explain what is going on here. So this is at its highest point, and then it comes down, hits the ground, bounces, so that's one bounce. Okay, and then until it hits ground the third time, this then will come up to its highest point again, 5 meters, come down, bounce again, up to its highest point and bounce again. So it's bounced, bounced, bounced. So there's 3 bounces and that is it, done. Tricky enough example. Okay, we'll finish there on that video. The next video we're going to look at is velocity time graphs.